How's it going, everybody? And I'd like to welcome you to our BGP section of our CCNP version 2 Route series for the 300-101 exam. My name is Rob, as you have probably found out already, and I'm trying something new. I've downloaded some webcam software so that I can turn my cell phone into a webcam through a USB connection. And I'm looking at the rate at which the video comes in on my screen compared to what I'm talking right now, and it looks okay. So hopefully the audio matches up and syncs up with the video. Let me know what you guys think. I'm only going to do a video or two like this, and once you guys see it, let me know what you think. I don't know if you guys even care to see me. Some guys do, some guys don't. I won't be doing this for every all videos, or I won't do it for every video, all video, but things like where I need to break things down or talk about different things. And I have to give a quick shout out, even though I'm not being endorsed, to Minicam. They have a free software you can download and install on your computer, and then it goes out and it finds the webcam, and it's actually much better. From when I'm talking to when I see myself on the screen, it's pretty quick, like almost instant. So it's actually a lot faster than some of the other software I've used. It actually allows you to do a lot more. I can actually capture screens with it and stuff like that. So we'll take a look at how that goes. And then when we get into some of the other like introductory videos, or if I want to, go teach a class and you guys want to see me full screen. There's a question, does it go full screen? Well, I don't know if you guys want to see me full screen, but it does go full screen. I'm not sure if I really like being full screen, but it does go full screen. With that being said, we're going to get into the technical content of our the BGP section. And BGP happens to be my favorite protocol, for my favorite internet routing protocol, besides OSPF. So any time I can work on an OSPF or BGP environment, I'm a happy guy. So BGP itself, if you don't understand BGP, it can be a little daunting, and I understand that. That's why I want to start out with give you guys an idea of what BGP is. And if you're brand new to CCNP, this would be a great place to start, because I go over the fundamentals, what BGP is and how to get things working and things like that. And we're going to go through different variations of how to get BGP operational and stuff like that. So, BGP itself is the Internet Routing Protocol, if you did not know that. So when you go out and you open up a web browser and you type in google.com, it uses DNS to go resolve the IP address, and then it looks in the routing tables of the Internet routers, which are BGP speakers, whether they are Juniper routers, Cisco routers, or HP, or whatever particular platform the ISP has running. They all support BGP because it is an open standards routing protocol. It is a path vector protocol. Remember back when I talked about the differences between distance vector, link state, and path vector? Path vector, the attributes of the route are what you manipulate. When you're dealing with the IGP, so distance vector and link state, you're dealing with the metrics, or the anything you would manipulate on the link level, so like the OSPF cost, the EIGRP delay, the bandwidth. Those are attributes of the link, not the route. So when you affect the link, you're affecting how all traffic is going to forward. With BGP, you can match it to the particular route. You can do all routes. You can go down to a particular autonomous system that you're receiving through the AS path, or using an AS path access list. And everything I'm going to be bringing up now, I'm going to break down as to what I mean by this. But you could go down for a particular subnet. You could go for a particular IP address, like a /32. So you have different ways of doing things, and you could affect the path selection for one route going left, where the rest of your traffic goes right. It just depends on how you want your traffic to flow. And BGP gives you that power. So it's a very, very powerful routing protocol. And one of the things we'll find out about BGP, the funny thing about it is, it never is fully converged. Like, what? Unlike OSPF, EIGRP, RIP, and ISIS, in order for convergence, if you will, to be functional and the network to be completely converged, all routers have to agree on the same forwarding path, or the same database, if you will, in most cases. So like EIGRP, you run dual to find the best path. Okay, OSPF, you run SPF to find the best path. RIP, you run Bellman forward to find the shortest amount of hops to get to the destination. May not be the best path, shortest amount of hops. ISIS, you run SPF to find the shortest path to where you need to go, because OSPF and ISIS both are link state routing protocols. They both use the Dijkstra shortest path first algorithm in order to accomplish their goal. So that's where we get that. So that's how you would do that. So if your IGP is not completely converged, you're not going to be able to forward traffic, and then only the best routes get installed in the routing table. Now, if there is, like, say, some convergence, where some routes have been agreed upon, some routes have been you've been able to dictate that those routes are good to go, and they're installed in the routing table, you might have some other routes that are either SPF is still running on them, or you might have a situation where dual has gone into an active status and you're looking for a backup path, or trying to wait for a query, or you're waiting on dual to figure out the best path based off of the feasibility condition. Whatever the case might be, that's the point that you need to come down to understand. Is convergence is a situation where all routers have chosen their best paths and have installed those routes into the routing table. Those routes are, per the protocol, been deemed to be loop-free and reachable. And reachable is a technicality, because technically they don't have to be reachable as long, and the reason I say they don't have to be reachable is you can have a null route in there, and you can advertise that route in. So we'll take a look at that, and there's a question, a null route question mark, and for instance, you can have an IP route or a static route pointing to null 0. So you can do that. So there's different capabilities, different situations that come into play when it comes down to that. But at the end of the day, it's one of those things where if you understand what convergence means, and you're looking at your protocol and you see certain little outputs that are showing you that there might be something going on, that's an indication that your network is not completely converged. So enough about that. But BGP is never fully converged, because if you look at the internet routing table, since it is the most scalable protocol out there, and because it has so many routes, 99% of the time, well, I should say this, 100% of every time I've checked, BGP has never been fully converged. There's always been some sort of route being advertised, a new adjacency coming up, and an adjacency going down. So, because that's one of the other questions I see is convergence. What is that? What affects convergence? Well, with BGP, it would affect a neighbor relationship coming up, a neighbor relationship going down. A route being advertised, about a route being manipulated, a route being removed. All these are things that would affect convergence. And so, when you're dealing with your IGP, you're dealing with you have all the links that are supposed to be up that are advertised, or in this case, the IGP process is enabled on the network statement that matches an IP address on an interface, and then you have everybody agrees on all the routes, and that the routing has been propagated throughout the network, and everything's good to go. So if you take those pieces right there and you run with them, that's what convergence typically means. Now, if any one of those is out of sync, or you're in idle, or you're waiting on routes to be propagated, best path selection is working, that's what makes BGP BGP. It's allowed to have, it was designed for that sole reason. Now, it's actually the successor to EGP, or the exterior gateway protocol, which was the predecessor to BGP. And there's been several variations of BGP, and I just lost my. That's okay though. So the idea basically with BGP is to route the internet, and there's several different variations of BGP that are out there, and we'll talk about them as we go along. We're not going to get into any. I don't believe I'm going to do any MPLS, but if you guys are interested in seeing how MPLS works on a very, very low scale, for instance, pull this guy up again. if you would like to see how MPLS is deployed, say for instance in a small environment where you have a single well, you wouldn't, if you don't know what MPLS is or what it does, it's going to be hard for you guys to understand what I'm talking about. But if you would like a very a CCNP level, so for instance, if maybe you work for an ISP and you'd like to go, maybe they have an MPLS team, for instance, and you want to move from the internet routing team to the MPLS team. And in order to do that, you need to know a little bit about MPLS and how it works. So I will show you guys, if you'd like. You'd have to let me know your feedback. I'll do the videos up after all the core stuff is done and stuff like that. That'll be more of a bonus video, but it would give you an introduction to what MPLS is and how it works. So if you would like to see how more of that stuff would work, you can either go to my my CCIE videos that I have. I go into an extreme amount of detail, way more than what you would ever see for CCNP, but the capability is still there. And I walk you through how to set up MPLS and get routes advertising and get one router. You know, if you have a site over here and you have a site over here, and you have a big MPLS cloud in the middle, you can get traffic from here to here through MPLS, and they could all be running RFC 1918 space. And I'm going to let you guess what RFC 1918 is, because if you don't know, that's okay. If you do know, great. Something for you to do a little bit of homework on. So what is BGP not? It's not a routing protocol per se. It's an application because it uses the TCP protocol to operate, and it typically it's a reachability protocol, meaning it's going to be able to get routes from point A to point B, but it doesn't technically know how to get it, what the next hop is. So if you're going to be dealing with IGP in the middle in your internal infrastructure, that's where you're going to want to get your traffic working with IGP, and then you're going to be using IGP to get traffic from this BGP speaker to this BGP speaker, and everything should work out from there. Just depends on the situation. So we'll take a look. That's going to be more of an iBGP situation, because in the real world, most of the time you just you redistribute a default route into like your IGP, and then that's where you go from there. So, but we'll take a look at how that works. So, now as we go through here, why would you use BGP? Well, it's easy to influence egress traffic. So I always choose how I route out, and it's easy to influence ingress traffic. So there's different capabilities to do that as well. So when to use BGP or not? That is a major question, and I get that question a lot when I'm dealing with customers. And the idea behind this is, who owns your address space? If you own your address space, that's what they call provider independent, meaning you had to form a peering with the ISP and advertise what routes you want the ISP to be able to provide reachability back to you or for you. The idea behind that is, if you own your address space and you go out to, IANA, and you get a autonomous system number, you configure all your routers, you do a bunch of peerings with the provider, you start getting a full view at the routing table. 500,000, if not more, routes in the full BGP table, and you start advertising your route. So you type in the network statement, and you yada yada yada, you punch in whatever you need to punch in to get your routes advertised that you want to have, and go from there. And then those routes are advertised into BGP, and away you go. Now your ISP might have a limitation to what it will accept, because it might have a prefix list installed on connecting to you, stating that if it receives anything less than /25, to deny it, because the point of BGP is not to route /32 addresses. The idea of BGP is to advertise a /24 or greater, because the more summarization you can throw in, the smaller the BGP table gets. Now that's not always the case, but that's usually a best practice. So, and there's a question: if you are using provider independent space, what is a common use case for getting traffic that you would want to be that's external to your network to be able to gain access to internal resources? Well, basically, to answer that question, the short story would be NAT. So, for instance, let's say, you have a firewall on your edge, and that firewall connects to a DMZ on the same box. and you have a bunch of policies set up in your firewall that allows certain public internet routes to be able to talk to certain DMZ devices. So, for instance, your externally facing web servers, your database servers. Typically, your database is going to be kind of hidden, if you will, from external traffic. So, only database ports might be permitted through the firewall to talk to each other, and you would have the web front end allowed to be viewed from the public internet. But your database servers that the web server is going to call back to for doing things like, doing a database lookup for like a username and password or a product description or something like that would be in a database somewhere. Those devices are going to be sitting behind the scenes. Whether they're physical or virtual is kind of irrelevant. They can be both if you would like. And if you follow along my VMware series and the Microsoft series that I'm working on, yes, I know I'm a Cisco and VMware guy, but I've been dealing with a lot of server stuff lately, and I figured it's a good time to start at least going through the material. And the Microsoft MCSA program that Microsoft has out there, that has the book that I'm reading on that it's like 32 chapters. So I figured if I go through a chapter a day and lab it up and take a look at it, you could comfortably go through an entire exam in 45 to 60 days, if you will. Spend a couple days on each chapter, make sure you understand what's going on. If you don't, Google it. That's usually how I go through. I don't move to the next chapter unless I know what's going on in the chapter I'm in, unless there's a caveat somewhere that says, you'll learn more about this technology in chapter 16 and you're in chapter 4. Whatever the case might be. But anyway, hopefully that answers your question. But the general idea behind that is, if you have a situation where you are trying to get external traffic to an internal resource, NAT is going to be how you do that. Is that the same with IPv6? Yes and no. If it's an IPv4 internet talking to an IPv6 internal address, yes, because you're going to be doing IPv6 protocol translation. And we'll talk about that when we get into IPv6 in the services section, where you're going to be translating from an IPv4 address to an IPv6 address, and then back and forth. But if it's an IPv6 internet to IPv6 internal, then no, because you're going to be you won't have to translate between v4 and v6. So we'll take a look at that as we go along. And there's another question: if you're dealing with NAT-PT, isn't there certain specific details that need to be in place in order for that to work? Yes, and I'll talk about that when we get to IPv6. But the long story short is, you need to make sure you have the right v6 addresses as mapped to the right v4 addresses, which is pretty obvious. But to take that a step farther, you need to make sure that you have, and I forget the exact detail, I think it's a /96 v6 address. You know what? To be honest with you, I had to look that up, as I'm not 100% sure. But basically, that's the point of using PT, or protocol translation, because you're going from one protocol to another. Because the IPv4 address family is different than the IPv6 address family, but you can run them in conjunction with each other, what they call a dual stack. And we'll talk a lot more about that in detail. So, does that answer your question? Perfect. Okay, cool. I'm going to move our provider aggregatable, though. Provider aggregatable is going to be the opposite side of the coin. Now, that is where the ISP owns your address. So, for instance, you went out to a particular provider and you went out and got address space from them, but they put a box in your environment that they manage. You connect your networking gear to theirs. For instance, Time Warner is notorious for ADVA or ADVA routers. They're fiber boxes. They'll take these boxes, they'll put them in a rack in your environment, they power them on. There's a fiber cable coming in, and usually a 100 meg Ethernet connection going between them and your device, and then all you simply do on your router is you create a default route pointing to them, and that's all you do. And then they take over from there. AT&T is kind of the same way with their Metro Ethernet service. They'll drop a Cisco switch in some cases, or it could be a Cisco router depending on the service that you're getting from them. And then what they'll do is they'll just have that box in your environment. They'll be able to manage it. So typically, 99% of the customers I work with are PA company or customers. they have a box on site and they hand it off to them. And or some companies even nowadays that don't have the Cisco guys to pull from or the Juniper guys to pull from, they'll just tell the provider, you manage all of the boxes. AT&T's got a service called MIS, or Managed Internet Services, and AT&T manages all that type of stuff. So that's basically how that would work. So BGP is needed when you own the space. BGP is not needed when you don't own the space. And typically, if you own the space, you're going to get a block of so many addresses. And let's say you've got a /24 from the provider, which in our diagram I have a /24 to use, so we'll be able to NAT things, and we'll be able to NAT to different what's the word I'm looking for? To different software services on the routers that'll be able to dictate things like we'll be able to do secure web and non-secure web. We'll also be able to do things like FTP, and then I'll have to look at what other capabilities we have. Like, for instance, if you wanted to test remote desktop services, we could have some sort of setup in there. And actually, that's how I remote into my house. I have remote desktop set up so I can remote in from the outside into my home network, and I use a NAT statement to do that. So I do. Some people refer to it as port forwarding, which that's a SOHO, or small office home office term. I like to refer to it as we're natting it, and because it makes it sound cooler, but that's okay. So as we go through, there's other things you need to be paying attention to, and some of the BGP considerations. How much BGP do you need? Do you need a full view? So if you don't need a full view, 500,000 routes, that's a lot of memory. And we're going to take a look at that as we go through, because at the end of the day, if you don't need that much memory, why chew it up? Why not just have a default route? So, and there's a thing called BGP ORF, or outbound route filtering, which allows you to signal to the provider what routes you want them to advertise to you. Now, that's kind of a corner case scenario, but you can do that, and we'll take a look at that when it comes to more of the advanced capabilities. But that is something you can do. And most of the time, you're just going to receive a default route, and that's going to be the extent of how that would work. Some of the other capabilities that come into play are going to be the scaling the enterprise with islands of IGP and core BGP. DMVPN works really well with iBGP because of how many networks you can have advertised, and we'll talk about that as we go through. I won't be showing you guys that. There's actually a technique where BGP does things dynamically, and that's a great feature to use with DMVPN. And some of the books that I would recommend you read is Internet Routing Architectures, TCP/IP Volume 2, Practical BGP and IP Routing, Optimal Routing Design by Russ White. Great reads, and that's pretty much the breakdown to BGP. Next video we're going to get into is going to be how BGP operates, and we'll take a look at exactly how that would work and go from there. So I hope this has been informative for you, and I'd like to thank you for viewing.